In this video, we're going to start talking about the actual hypothesis testing. Now that we covered a sampling, a distribution of the mean, and the central limit theorem, which is the basis of hypothesis testing, now let's see how do we formulate hypothesis tests. What are the first steps? So let's start with some examples, some very simple examples. Consider the following statements about the engineering students at Cal Poly Pomona. So these are some statements that we don't know whether they're true or not, but they can be our hypothesis, right? The average GPA is 3.0. The standard deviation of age is 5 years. 30% of them are afraid to fly, and the average age of their mothers is the same as average age of their fathers. So these are some random statements, essentially, about these students, and we don't know whether they're true or not. Each one of these statements can be actually turned into a statistical hypothesis test. And these statements, each one of them, will be our null hypothesis. And we show that with H naught. So these are all null hypotheses, basically our assumption that, hey, let's see if they're true or not. So when we say the average age is, the average GPA is 3.0, first of all, we're referring to the average of this population. Average of any population, we show that with mu. So basically what we're saying for H naught, or our null hypothesis, is mu is equal to 3.0. So that's our null hypothesis. Or when we say the standard deviation of the age is 5 years, we're referring to standard deviation of the population. So sigma is the parameter that we're going to hypothesize on. So what we're saying is sigma is equal to 5. Same with the others, 30% of them afraid to fly. In this case, we're not referring to the average or standard deviation. What we're referring to is the proportion of this population. And we show proportion with P. So what we're saying is P is equal to 30% or 0.3 proportion. And then in the last case, we are referring to two different populations. The average age of mothers is the same as average age of their fathers. So here we're having two different population average, mu1 and mu2. What we're saying is for the null hypothesis, mu1 is equal to mu2, or you later see that a better way of writing this down is mu1 minus mu2 is equal to 0. So this is the first step. You have some hypothesis, you turn it to your null hypothesis. Now, in order to investigate and formulate the hypothesis testing further, you probably have some contradictory statements in mind, right? So you probably have in mind that, hey, the average GPA of the students is more than 3.0, or standard deviation is not 5 years. Less than 30% of them are afraid to fly, and average age of mothers is less than average age of the fathers. These are some contradictory statements, and this is another piece of your hypothesis test. Each one of these statements will be your alternative hypothesis, and we show that with H1. So we have a null hypothesis, and then we have an alternative hypothesis, and they contradict each other. And the goal is to go through this process of hypothesis testing and prove which one is correct. That's the final goal. So if we want to write down our alternative hypothesis, would be mu is more than 3.0, sigma not 5 years, so sigma is not equal to 5, less than 30%, so P is less than 0.3, and average age of father is less than average age of, mother is less than father, so basically mu1 less than mu2, or in other words, mu1 minus mu2 is less than 0. So now by having these two, we are basically, we took the first steps of formulating a hypothesis test. There are some guidelines on how to formulate and how to take those first steps. First is you have to understand, are you talking about one population or two? In all of these examples, we were talking about one population, except the last one. This last one, we have two populations. So this is the first thing to look at. Are you doing a hypothesis test on mean, standard deviation, or proportion? Right, so here was, for example, proportion. And here was standard deviation, here was mean. So this is something else. And then you define your notations, basically what is your mu, what is your sigma. And then the next step is to formulate your alternative hypothesis first. Something very important here is that the burden of proof is on alternative hypothesis. Whatever you're trying to prove goes to H1. If you're trying to prove that the GPA is more than a certain value, then that's your alternative hypothesis. Along the same line, a very, very important point that a lot of time is a point of mistake is that H1 never includes statement of equality. What does that mean? So in your alternative hypothesis, you never have an equal sign. You never say mu is equal to 3.0. That is not correct. H1 always has more than, or not equal to, or less than. Never has equal sign. And specifically in quality control applications, the statement of bad quality goes to H1. And you'll see some examples of that later. Then you formulate your null hypothesis, and this statement is assumed to be true. So in the premise of your hypothesis testing is that H naught, or null hypothesis, is assumed to be true. Now let's see if we can find enough evidence to reject that. But the premise is H naught is true. And again, this is another very important point and point of mistake. H naught always has statement of equality. So the equal sign, mu is equal to 3.0, proportion is equal to 30%. All of those equals goes to the null hypothesis. So keep that in mind. It's very important. We'll continue this discussion and we'll talk about the next steps of formulating hypothesis testing. So far, we talked about the null hypothesis and alternative hypothesis and how do we set that up.